Statistics, Chapter 8, Lesson 2. Today's is the distribution of the sample proportion. So we're going to describe the sampling distribution of a sample proportion and compute the probabilities of this as well. I do want to remind you that this is read as p hat, okay, that is given by x over n. So describe the sampling distribution of a sample proportion. So first off, we have to have a point estimate. So our point estimate of a population proportion, for example, if I want to know how many people are in favor of how the president is running the country at this time, and I had interviewed 200 people, and let's say 150 of them were in favor of how he's running the country, my p hat would be the 150 divided by 200. So we have to have a p hat. We have to have a point estimate about what our population is about. So in this university poll conducted in May of 2008, 1,745 registered voters nationwide were asked whether they approved of the way George W. Bush was handling the economy. 349 had responded yes, they were. Obtained the point estimate for the proportion of registered voters who approved of the way George W. Bush was handling the economy. So again, our point estimate would be that 349 out of the total of 1,745. So at that time, 20% of the population was in favor of how he was running the economy. Now, will this be the same every time I take a new sample? I hope you're saying no, because when we do a random sample, it shouldn't always be exactly the same. My next one might be 355 are in favor. Maybe another sample leads to 500s in favor. Maybe another sample, 200s in favor. See, that's the whole idea of doing samples. You take several different samples, and we'll take the averages of those, and to try to get us a better idea of really what represents the population of our country. So the Time poll had conducted in June of 2008, 42% of registered voters believed that gay and lesbian couples should be allowed to marry. Describe the sampling distribution of the sample proportions of sizes where n was 10, n was 50, and n was 100. Now, they had used the simulations to create these histograms below. If you notice, this first histogram looks a little bit right skewed to me. It's not very symmetric. I want you to notice the one on the right and how symmetric that one looks. That one looks very close to a normal curve. See, the larger your sample size gets, the more normal your sample proportions will get. In other words, they'll be closer and closer to a true approximation of what's really happening. Again, like I said, this one here had the mean of 0.426, standard deviation of 0.1. Notice the larger your sample sizes get, 50 my sample, my standard deviation now smaller. 100 my sample, my standard deviation is even smaller yet. So again, the shape of it, the size, as n increases, the shape of it gets approximately normal. The center remains about the population, like the mean. The spread, that's the standard deviation, it decreases as n gets larger. So the sampling distribution of p hat. So first off, the NPQ has to be greater than or equal to 10, and the number in the sample must be less than or equal to 5% of the population. If these conditions are held true for a binomial distribution, then the mean of the sampling distribution would be equivalent to the proportion, and the standard deviation for p hat would be the square root of p, I always call that q, over n, and that was the square root of all of that right there. And again, please look at Chapter 8's formulas real quick. Flip your card over to the back side for Chapter 8. Take a look at these formulas because we're going to be using these on the next several slides. So according to the Time poll conducted in June of 2008, 42% of registered voters believe gay and lesbian couples should be allowed to marry. Suppose we obtain a simple random sample of 50 voters and determine which voters believe gay and lesbian couples should be allowed to marry. Describe that sampling distribution of the sample proportion of registered voters who believe they should be allowed to be married. So first off, n, 50. 50 is definitely less than 5% of our population size, so that had to be met. The next thing that had to be met was that the NPQ had to be greater than or equal to 10. Well, my N was 50 voters. P was 42%. 1 minus the 42% was the 58. That gave me 12 and 1800s. That's definitely more than 10. So then we may proceed. Therefore, our sampling distribution for the proportions, the sampling distribution of the sample proportions is approximately normal with a mean of, and that was your P, 0.42, standard deviation of P, Q, that's the 1 minus 0.42, divided by N, and the square root of that, and that would be my standard deviation that I would use. So according to a study conducted by a statistical organization, the proportion of Americans who are satisfied with the way things are going in their lives is 82%. Suppose a random sample of 110 Americans is obtained. Describe the sampling distribution of p hat. So again, remember that n would have to be less than or equal to 5% of the population. So we have 110. 110 is definitely less than 5% of the population of America. The next thing that would have to be met would be NPQ would have to be more than 10. So my N was 110, the P was 82%, the Q would be the 18%, 1 minus the 82. That is 16, that's definitely greater than 10. If these two conditions are not met, then you cannot proceed on with this question. You would not be able to you wouldn't be able to decide if this sampling distribution of p hat is normal or not. Since these two conditions are met, we will then say the sampling distribution for proportions is normal, it's approximately normal, with a mean of, notice this is saying the mean and then sub p hat. See, this is the mean for the proportions. So the mean for the proportions is at 82% and the standard deviation. And then standard deviation was the PQ over N and the square root of that. So use this distribution from part A to find the probability that at least 82 Americans in the sample are satisfied with their lives. See, when I'm saying at least 82 Americans, that's referring to an X of being 82. But this is all about a proportion. So I'd have to convert that to a proportion. So to do that, that would be the p hat to be 82 out of 110. Now, I would need to get this to a z-score. So I would have to take this value, whatever this equals, take away the mean of 0.82 and divide it by the standard deviation. That will give me my z-score. So again, to get the z-score, remember you take this value minus the mean, enter, divide by the standard deviation. So pause it, you type that in and make sure you're able to get the z-score. If you're not, when you come back to class, ask me how I got the z-score. So again, it was that value minus the mean, divide by the standard deviation. Now at this time, I want the probability that z is more than that value. So that would mean a normal CDF from that value to 100. The lower bound being the negative 2.0368, the upper bound being 100. The next one is what's the probability that 77 or fewer Americans in the sample are satisfied with their lives? So again, the X is 77. It's not a proportion. Remember, these are all about the proportions this time. So I'd have to convert that to a proportion. That was 77 out of 110. I would get this value. After I get that value, top divide by bottom, enter. Then I'm going to minus the mean of 0.82, enter, and divide by the standard deviation. That will give me my z-score. Now I want the probability that the z-score is that value and less. So therefore my lower bound would be the negative 100. My upper bound would be the negative 3.2787 under a normal CDF. So that was second distribution. Normal CDF, negative 100 to this z-score. And that one is definitely very unlikely to occur. Because remember, anything under 5% is not likely. It would be unusual. So according to the Centers of Disease Control Prevention, 18.8% of school-aged children 6 to 11 were overweight in 2004. In a random sample of 90 school-aged children aged 6 to 11, what's the probability of at least 19% of them are overweight? And B, what may you conclude if 24 of the 90 are overweight? So first off, let's make sure our NPQ is greater than or equal to 10. It was at 13. So again, the N, how many was in our sample? Okay, 90. P, the percent that was overweight, 18.8%, so that's 0.188. Q is 1 minus that P, and that product was 13.7, definitely more than 10. And then 90 school-aged children is definitely less than 5% of the population of all school-aged children in our country. So then we may go ahead and proceed on. That p hat is approximately normal with a mean of 0.188, standard deviation of the square root of PQ over N. So A wants the probability of at least 19% overweight. Notice this time it's at least 19%. That's already a proportion. So I need to take the 19%, take away this 18.8%, divide by the standard deviation. Again, the value minus the mean, divide by the standard deviation is your z-score. Now I want the probability that z is greater than that, so that would mean a normal CDF from that z-score to 100. I want from that z-score and to the right. So the left bound would be the 0.0485, the upper bound would be 100 on a normal CDF. Now, problem B says, what made you conclude if 24 of the 90 kids are overweight? See, if 24 would be an X value. That's not a proportion. So I'm looking for the proportion, remember, because this is all about the proportions here, not an X. So 24 out of 90. I take this number and divide it first. After I hit enter, I subtract the mean, divide by the standard deviation. It gives me my z-score. So again, we take the value minus the mean, divide by the standard deviation. So I want the probability that z is greater than or equal to 1.9102. That would be a normal CDF from that z-score to 100. So 1.9102 would be my left bound, 100 would be my upper bound. And that's only going to happen 2% of the time. So that would be unusual for a group of 24 or more kids to be overweight out of a group of 90 if this is the obesity rate in our country. So if we have a school that has more than 24 out of 90 that are overweight, something's wrong. Something's wrong in that community. Kids aren't active enough, or maybe the kids have to stay indoors too much. There's something going on that maybe is causing the children in that area to be more overweight than the rest of the country. So according to a study conducted by Statistical Organization, the proportion of Americans who are afraid to fly in 2006 was 10%. A random sample of 1,200 Americans resulted in 108 that were afraid to fly. Explain why this is not necessarily evidence that the proportion of Americans who are afraid to fly has decreased. So first off, my NPQ, that was 108. So it's definitely bigger than the 10. And 1,200 is definitely less than 5% of the population of Americans in our country. So if I proceeded on, therefore the p-hat would be approximately normal with a mean of the 10% and the standard deviation as following. And so we're looking for the probability that X would be less than or equal to 108 of them. 108 afraid to fly. So in a random sample of 1,200 Americans results in 108 that are afraid to fly. Well, again, I need this to be in a proportion. So that was 108 out of 1,200. As a proportion, that is equivalent to 9%. Now I need to get a z-score on that, so I take this value minus the mean, divide by the standard deviation. That's how we get a z-score. Again, the value minus the mean, divide by the standard deviation. Now I need to run a normal CDF from negative 100 to that value of z, because I want the probability that z is less than or equal to. So therefore, negative 100 is the lower bound, negative 1.1494 is the upper bound, and that probability would be 12.53% chance of that occurring, that 108 or less would be afraid to fly out of a random sample of 1,200. So it wasn't unusual. So again, a sample proportion, the p-hat is denoted by for x over n. The sampling distribution for p-hat is normal, provided that NPQ is more than 10 and the sample size is less than 5% of the population. Then this would be your mean and this would be your standard deviation. And then we computed the probabilities of each of those. We would compute those to a z-score. From our z-score, we then did a normal CDF, and that would give us our probabilities. And remember, things that are under 5% are unusual. I hope these notes help you. You guys have a great day. Thank you.